Um, this is not going to be a technical talk. This is going to be, of course, I'm going to show a demo, but this is more about the dilemma that's happening in the open source AI world. The title of the talk is The Open Source AI Dilemma and the Need for a Model Openness Framework. And a quick introduction about me is I'm Raghavan. I'm a senior engineering manager at Search AI at LinkedIn. So if I use LinkedIn Search, my team is responsible for the machine learning algorithms behind that. In the open source world, I am part of GenAI Commons. I co-lead education and outreach work stream, and I also co-lead the applications work stream. We recently developed a interesting prompt engineering technique to improve LLM's quality for low resource languages like South Asian languages or Eastern European languages, which does not have significant representation in LLM's training data. I'm also an Apache Solar contributor, and I also spend some of my time helping UN-ITU, which is UN's disaster management wing. The contents of this presentation is a work of many. I cannot take full credit. It's a work of many at GenAI Commons who developed this model openness framework and built annotation tooling around it. And I'm trying to evangelize some part of it, and I also built some part of this annotation tooling. Cool. The agenda for today's talk, I'll quickly, I think most Onyx people know what LFA is, so I'm not going to venture much into that. And I'll quickly talk about what GenAI Commons do, and then model openness framework, and this open dilemma that we have today. As most of you know, LFA, I think most of you know already about LFA in data, but just in case if you don't know, it's the not-for-profit organization that hosts critical components for AI in data. It has three components: the governing board, TAC, and GenAI Commons. I am part of the GenAI Commons, and as it was founded in 2018, it has more than 75 members, 75 member companies, and the repositories have more than combined 250K GitHub stars. The GenAI Commons is a community that is within the LFA plus data. Within the umbrella of LFA in place data, we are trying to shape the future of generative AI through open source and open science. And there are 5 work streams within GenAI Commons. They are the frameworks work stream, models and data work stream, applications work stream, responsible AI work stream, and education outreach. I am part of the application and education applications work stream and the ENO work stream. Cool. With that, every single day, you will hear the word generative AI in your newsfeed in one of your social media. And every organization, some organization is releasing some large language model or diffusion model every other day. But what is really open? Does anyone know? There is this hashtag open washing going on where the organization releases a subset of these components to be open, but puts this label of open source for their entire work. And because of this ambiguity around openness, it definitely creates some risks, and there is a need for clear framework for assessing what is truly open versus what is partially open. And to some extent, a truly open model accelerates innovation and level plays this entire field. In order to sell anything, you have to tell what is it that you will miss, what headache would you have if you are not able to, if you don't have that. And obviously, you have to tell the benefit of it. There are 2 ways of selling things. One is you have to tell, if you don't take this medicine, you're going to get headache. Or if you take this medicine, it's going to improve your calcium levels. So let's take a hypothetical example. Most of the generative AI applications that you will see is some chatbot. So let's say there is yet another AI startup that generates yet another chat that's building another support chatbot. And they saw this new open source Lamstrel model, a pre-trained model, and the authors of Lamstrel marketed it very well to be an awesome open source model that they can use. But later they discovered that the license of Lamstrel prohibits, it's restrictive enough that it prohibits commercial use. And that training data and code is not released. Because of that, it may expose the startup to a legal risk. This alone highlights the need for model openness framework that standardize things, and it's easy for startups or anyone to use these so-called open source models that are out there. And I personally did not know until I joined this work stream that the last license of Llama LLM is not truly open source. I used to think that Llama license is truly open source. Until I joined this work stream, that's when I realized that the license for Llama LLM is not truly open source because there are clauses within it that makes it restrictive. And obviously, just as I said, there are two ways of selling it. One is to tell what headache would you get if you don't adopt it, or if you don't have it, and what are the benefits of it. And as I said, the benefits of a truly open source model is there is some legal confidence, and anything that's in open source is open for audit. And one can there is an ability to audit for bias and improve performance, and it also reduces barriers, the barriers to build AI-powered products. And as I said, it's a level playing field. It makes it a level playing field. So the model openness framework has 18 components, and these components can be split across code, data, and docs. And I keep forgetting these definition for some of these components, so I have them handy here. When a large language model is released out in the open, each of these 18 components, or the MOF file is an output, but all of these components should have a non-restrictive license and should be made open for easy reproducibility. For example, evaluation code or the pre-processing code is a code that is used for pre-processing your initial training data set and compute tokens out of it, or the code that is used for building tokenizer. And model architecture, as you know, is I saw in the previous in one of the previous slides, there are many different types of attention, and model architecture should clearly explain what type of attention is used so that it helps with reproducibility. Now, we have come up with a set of accepted open licenses for each of these components. You can see that anything that is related to data should, the preferred license is Creative Commons by 4.0, CDLA permissive 2.0 license, and anything that is related to code, the acceptable license should be OSI approved, and usually it's Apache 2.0 license or MIT license. And based on this, we have developed 3 classes. The model openness framework has developed 3 classes. One is class 3, which is open model, where whoever who has released that LLM model has made the model weights, model architecture, the technical report, the evaluation results, and model card to be open, but it's not reproducible for you. You can take that model, you can build applications on top of it, but it's not reproducible for you. Class 2 is they have open source all of these, and on top of that, they have also open sourced training code, inference code, evaluation code, evaluation data. So it is one step towards reproducibility. And class 1 is open science, where the most important thing is data sets are now open. So if you have sufficient resources, you should be able to reproduce that work as is. So the 3 classes are open model, where the weights are available for you. You can build applications on top of it. That's great. But it's not reproducible for you. Open tooling, the training code, inference code, evaluation data is provided and is made open source. So it's possible to at least build a model like that using different data set. Open science is when everything is open, where you can completely reproduce that work. So at GenAI Commons, we took the task of annotating some 200 plus models. The last time I checked, this was 200 models. Now I think it's okay, still 228 models. And we annotating these models across those 16 components is a tedious task. So this is where I contributed, where I helped develop a simple application where it can, given say a model, we use an LLM to identify what parts of that LLM is open or not. So hopefully demo gods do not, I have already things open here. Okay. So for example, the crystal coder, we are not able to find the training data set. but we are able to find the model weights, and those model weights are in Apache 2.0 license. And the inference code is also available with Apache 2.0 license. And a technical report is available. I'm hoping that this technical report is right. So if I copy paste this, it is about LM360, that is Crystal Coder. And this is LM360's Crystal Coder, that's it. So we have this annotation tool. This is not the mod tool. There is a separate tool called mod tool that helps with annotating all 16 components. This is just information gathering tool to do that annotation. So we are in the process of annotating more than 200 plus large language models, and that in itself is a tedious task. As part of this framework development, these are some of those things that are out of scope. For example, AI safety, bias and fairness of that model, red teaming. As of now, we are in the process of creating a responsible AI framework. So if you want to contribute, feel free to join GenAI Commons and you can contribute to this responsible AI framework. And how this helps model producers is this actually make model producers release more components to actually get that open source label. So if we are able to have the three classes, class 3 of just open data and then open tooling and then open weights, open tooling and then open science, this kind of incentivizes model producers to release more components using open licenses. And obviously for model consumers, it goes without saying, you get that clarity of you get that clarity of what is truly open versus what is just open washing. And these are some of the models that are in validation phase, where we are working with folks Arctic is from Snowflake, Llama 2 is from Facebook, Mistral, Falcon, Pythia, where we are working with them in validating their class, the class under which their model falls under. And in the interest of time, I will switch to this one slide. There is a huge spectrum of opinion of should we open source AI. And there are a set of people who believe, hell yes, because this is an important tech and it has to be accessible to everyone. And centralization is against open, centralization of anything is not good. And it also helps with diversity. It will allow actually, because open source allows for audit, it improves safety and alignment. And there is another completely other end of the extreme where there are people who the opinion is that this technology is harmful and it's easy to remove the safeguards. And what about intellectual property rights? And the main debate is, should the data, the training data that is used for training that model, should it be made open, or should it not be made open? That's where the debate is. And if you really want to contribute, please feel free to look into opensource.org/deep dive. And an effort like this requires global input because this has a global impact. With that, I'm happy to take some questions.